In this video I'll be investigating Boyle's law, which looks at the relationship between gas pressure and the volume of the container the gas is occupying. It does so for a fixed mass of gas at constant temperature. This is the apparatus I'll be using. This is a pressure gauge here, which will be measuring the pressure in kilopascals. The outside scale here is kilopascals, the red scale. So at the moment this is at atmospheric pressure, which is just over 100 kilopascals. This is the column of air that I'll be investigating, and that's sealed off by this oil, which you can see here. So that's the actual volume of gas I'll be investigating. The scale on the volume counts down, so we've got 5, 10, 15, 20, 25 and so on, counting down, because as this oil moves up, the volume is getting smaller for the air in there. I'll use this pump to pump up the pressure, increase the pressure in this apparatus here, and I'll pump it up to 210 kilopascals. We'll note down what the volume is, and then I'll gradually release the pressure and stop at each of these intervals so that we can then record the volume for each of those. We'll be trying to find out whether pressure and volume are directly or inversely proportional. So the extra columns here are to do a test. Firstly, pressure divided by volume. If all these values are the same, then pressure and volume are directly proportional. If all these values, pressure times volume, are constant, then they are inversely proportional. So that data will go in there. Okay, I'm going to pump this up and we'll start collecting some data. This is now 220 kilopascals. I'll reduce the pressure to 210 and we'll record the volume. Okay. 210, and that's at 17 mils. My volume, I'll now calculate pressure divided by volume and pressure times volume on my spreadsheet, put the data into the spreadsheet, and then we'll see which relationship we have. We can see that as the pressure is reducing, the volume is increasing, so we should find that it's not directly proportional.